Welcome, my dear students. We have today episode. Do you know about what? It's about Unit 4. I know you like Unit 4 because it talk about the patterns, different patterns, and the elimination in our life. Are you ready to make a revision with me? Yes. Good revision to get what? To get our target, our opinion. I need a full mark. You must be ready for that. Let's go and see together. Choose the correct answer from A, B, C, or D. Multi-choice, it means more concentration. Which of the following process looks like the galvanization process? Galvanization, yes, I know. Covering the iron with the zinc, you remember that? Yes. I have plating iron rod with tin, or welding copper pipes with lead, or connecting the magnesium electrode with the iron pipe, or covering a copper pipe with a layer of epoxy. I can say welding the pipes with the lead. It's look like galvanization, which is covering by iron, by zinc. If you remember, here I make a welding between copper pipes with what? With a lead as a cover. Also, the following figure show a battery which gives an electric current, produces bubbles in the two test tube. The first test tube, I have a two test tube, I have a pools, and I have an aqueous solution, Na2SO4. Now, which of the following best shows the investigation result in the chemical change? I can say liquid condenses on a cold glass rod with a gas from the test tube on the left is released, or gas prop indicate the water in the beaker containing dissolving nitrogen and oxygen, or a burning wood splint placed above the mouth of the test tube on the right glows bright when some gases is released from this test tube, or the temperature of the wire connected to the battery increase. I say here the good answer, burning wood. When I put it at the above of the tube, I have a brighten here according to the gas that evolved, strong gas. You see, it's very important. When I catch this question, the standard reduction potential of hydrogen in fuel cell equal. Standard? Yes, standard. It means yes, constant. What this? Fuel cell may be 0.83 or 0.83 by negative, or 0 or 0.4. Which choice is right? I say here standard negative 0.83. Why? Standard of fuel cell. Catch this question. Which of the following sentence is wrong? He say right, no, is wrong. It means concentrate for each sentence for this. He give me half oxidation and reduction occur at the electrodes in the electric cell. Why not? I think it's right. What about this? The reaction in all electric cells involve oxidation and reduction reaction. Cells has a oxidation, has a reduction. I think, why not? What about this? All galvanic cells require the electric current to start non-spontaneous chemical reaction, or the reduction occur at cathode. I need what? I need a wrong. So the wrong is, yeah, all galvanic cells require electric current to start. Yes, this is wrong one. Galvanic, yes, galvanic doesn't need electric current to start. You remember this important question. Another one, the following reaction occurs in galvanic cells. Cu aqueous plus Cd cadmium in solid state give me Cu solid and Cd aqueous. Do you think it's right? No. I must say Cu positive 2 ions. Cadmium is a positive. Yes, this is for the result. I start from what? Cu ion to Cu solid. Cadmium starts solid and they change in the aqueous. Do you know what this means? Yes, we know. Which of the following sentences describe what? The direction of electrons. Oh, direction and the nitrate ions. Look, nitrate ion moves to cadmium half cell and electrons to cadmium electrode in the electric cell, or nitrate ions moves to copper half cell and electron to cadmium electrode, or nitrate ion move to cadmium half cell and electrode to copper, or nitrate ions move to copper half cell and electrons to copper electrode. The answer here, we can say nitrate ion moves to cadmium half cell. Why? Because it starts from solid to aqueous. Solid to aqueous oxidation. You remember this oxidation process. You see, it's very important to say that. Another one, and electrochemical cells. These reactions occur. 2 Au aqueous is a positive plus zinc 3 Zn is a solid. Au solid and Zn. Positive what? Positive 3. Au start from the ion, it change into solid. Zn start from the solid, it change into ions. This oxidation and reduction. But which one oxidation, which one reduction? That's what we need to know. Look at this. Which symbolic express represent this reaction? I can say for number A, 2 Au positive 3 half cell and 2 Au, the other half 3 Zn and 3 Zn positive, ion to concentrated solid and Zn solid to the ion, the other choice. Au to Au ion solid gold to ion of gold, or Zn solid to ion of Zn. Do you think it's right? Or 3 Zn 2 Au ion and 3 Au and 2 Zn positive, the other half. You see, the cell, it has two halves. Last one, 3 Zn, 2 Zn3 or 2 Au. Directly, we start for last one. Why? Why we choose number D? Because number D here has half oxidation and the other half of the cell reduction. Don't forget, both are parallel. Oxidation and the reduction are happened here. You remember? Let's go to this question. When I say for you, on comparing lithium metal that lies in the highest of electrochemical series with copper, lithium and the copper, lithium is the first, copper down under hydrogen, lithium more active than the copper. What you need? We found that standard potential of the lithium and Li means lithium for the other half less than Cu, lithium ion to lithium solid, then copper ion to copper solid. Standard potential here is right. What about the standard potential of Cu positive 2 ion to Cu less than Li positive 1 and Li for the other half? Take care. Cu ion to Cu, good, to Cu solid. What about C? standard potential Li positive 1. The other Li less than Cu to Cu positive 2. Last one, lithium atom is less than the kappa on its volume. What is the answer? Lithium is active. So I say standard potential of lithium for the first half, ion to solid. Kappa from the ion to Cu solid. You see, number A is the right answer. Why? According to the activity of the lithium. Catch this question. If you are given that the following half cell reaction, Ni2 in aqueous state positive plus 2 electrons, give me Ni solid, electromotive force E node equal negative 0.25 volts. To care from this number, 0.25 by negative Hg2 in aqueous state plus electrons to electrons, Hg in liquid state, E, its electromotive, equal positive 0.86. Two numbers. Do you think which are given this reaction? What you need? I need here to calculate the electromotive force E cells for this cell. But take care, which of the following reaction occur? You can say H2 in aqueous state, positive 2, plus Ni solid, give me N2 positive in aqueous state plus Hgi. N2 aqueous. So Ni solid. What I do here? I can make minus. I say positive 0.86 volts minus negative 0.25. You remember? So the answer is easy. 1.11 positive 0.61 positive 1.11 positive, no, negative 0.61. Which one is right? I can say number C. Remember, because the highest number by positive 0.8 by positive state, when you make a minus, negative by negative equal what? Equal positive. So the highest here 1.11 volts. Good question. Which of the following is the correct about a standard? Yes, you know, standard is a constant electrode in the half cell. What this? It's open circuit when no electrons flow through it. Oxidation takes place on the surface of electrode which emerged in it. Reduction take place on the surface of electrode which emerged in it, or its reduction potential equals 0. Good question. It's not difficult. I say if you open circuit, no electrons follow through it. Yes, I know. This is our standard. What you know? No electrode, no charges, no electric current. It's standard here. Good question. When I say which of the following ways enables you to identify an unknown metal which oxidized by losing one electron. How can you know unknown metal? By losing electron. Let's see. Formation of electric cell and measuring the electric current, or determination of the change in the temperature of the metal when it's oxidized, or measurement the metal ability for oxidizing the iron 2 ion to iron 3, or formation of an electric cell from this metal form against the standard hydrogen electrode. Yes, I say this right directly. Why? Electric cell for this metal come from against the opposite, the standard hydrogen electrode. Good question. So I can find the metal. Easy to know that. Another one, I have 3 test tubes, A, B, and C. Each of them contains suitable amount of what? Diluted hydrochloric acid. It's good. Take care. You have hydrochloric acid, but dial. Yeah. 3 different metals are added to A, B, and C, the 3 test tube. After a period, we investigated the following observation. What happened? In the tube number 1, there is gas bubbles are slowly evolved at its mouth of the tube. Take care. Bubbles. Gas bubbles, but slow. Second one, gas bubbles are rapidly evolved at the mouth, very strong. Slow the first, the second one strongly, rapidly, third one, no gas. No gas or bubbles are evolved? Yes. What do you want from this question? I have only HCl. When you add metal, no gas for the number 3, strong gas for number B, gas weak for number A. Yeah, which of the following choice represent the 3 metals are added? What we add? Test tube 1, 2, 3, A, B, and C. Number A, we add copper to number A, which is slow. Zinc, here is the faster. Iron, here, no. Do you think it's right? Or magnesium in number A and the slow gas, iron in number B and the strong gas rapidly, no in copper, or zinc in number A, so it's slow, number B magnesium, so it's rapidly, copper in number C, so no gas, or zinc, magnesium, and iron. My dear student, you catch the answer? Yes, it's easy. I catch the answer. If you concentrate for the activity for the element, yeah, I can find the answer as you see. What? Zinc. Yes, it's zinc. So, magnesium, yes, very fast to HCl, very fast because hydrogen gas evolved. Copper, no reaction because it's a weak element in chemical activity. Serious. So the good choice number C. Catch this. Iron rust is an electrochemical process in which the cell reaction is. It's rust. Yeah, it's rust. There is oxidation. Iron 2 Fe positive 3 and the water is reduced to H negative. Do you think it's right? Or oxidation iron 2, iron Fe positive 2, and the water is reduced. The difference between them, the first iron 3, the second iron 2. Do you think it's right? I don't know. What about to get this question? Oxidation of iron 2 happened here to Fe positive, and the oxygen dissolved in the water is reduced to H negative, or last one, oxidation of iron 2 to 3, and the water is reduced. I think all of this is very important. Which one is the suitable? Yes, I know, the suitable Fe positive 2 oxidized. What happened? Oxygen dissolved in the water. When it dissolved, it reduced to what? To OH negative. You see, oxidation and reduction occurred at the same time for this rusting. Easy and important. Fly to this question. The amount of electricity required to precipitate 1 gram per atom of copper. What you need? Amount of electricity. Q, remember, Q, we studied Q equal what? I by T, remember? According to this reaction, how many Faraday? Faraday, which is a constant, 2 electronegative plus Cu positive 2 in aqueous solution, give me Cu solid. Now, A, half, 1, 2, or 4? I say it's 2 according to the last equation. Concentrate to find Faraday. This question, the value of the electromotive force for the following cell, E cell, electromotive force for the cell, equal. Yes, what will be? What this? I have E 0.80. I have the other one, it will be 0.34. Ag positive and Cu positive 2. Now, the question tell you the result of EMF 0.8 volts minus 0.34 volts or 0.34 volts plus 2 by 0.48 volts or 0.34 volts minus 0.8 volts or 34 volts minus 2 by 0.8 volts. The answer here is very easy to tell you. You make a minus. First from the second. 0.8 volt minus 0.3 volts. According to what? According to last figure. Catch this now. Precipitation of the atomic mass of trivalent metal, trivalent car, require the amount of electricity equal what? I need to find amount of electricity from trivalent metal to pass through solution has only one of its salt. What I say here? 9650 or 96500 or 28900 or 289500. Yeah, the answer here number D. How? Don't forget I have 3 trivalent. I get Faraday number means 96500 by 3. The answer number D, 289500. Good. You know from where? From trivalent. 4, it's a constant number. Another one. All of the following changes occurs on putting a piece of zinc in copper 2 sulfate solution. All of them a change except, take care from the except. Zinc and the copper sulfate. Except what? Look, zinc covered by a layer of copper or produce thermal energy or electric current is produced or decrease the color of intensity of the solution. Yeah, the answer is very easy. Electric current is produced here, you see. Another one, which of the following metals has least what? Least ability to lose electron during a chemical reaction. Can't lose electrons. Yes, I say. Standard reduction potential are given between brackets. Standard, yes. Let's see the standard. Mercury 0.851, zinc negative 0.762 volts, copper 0.34 volts, or lead negative 0.126. Concentrate for the answer. What you need? I see here the highest number, the highest volt here. Which one is the highest volt? Is the mercury, so I use it. Which of the following metals has the highest ability to lose electrons during the chemical reaction? Highest to lose electrons? Yes, I say. A standard reduction potential are given as you see. Cu positive 0.34 volts. Highest to care. I need the highest. Pb negative 0.126 volts. So cobalt negative 0.28 volts. Rb negative 2.925 volts. Sure, I need the highest. Yeah, rubidium. Why? It's negative. Yeah, I need the smallest number here. Which one is the smallest number? Negative 2.925 volts. Highest standard potential, we get the smallest number for the element. Catch this question. The function of the salt bridge in galvanic cell. Salt bridge, I know this, it's really easy. Allow the passage of the ion in the direction of anode only, or allow the passage of cation in the direction of the cathode only. Anode only or cathode only, or act as barrier to prevent the rapid mixing between the solution of the two half cell, or act as a barrier to prevent the direct mixing of the solution of the two half cell and to reach the what? Neutralization state. The answer is prevent the passing of the salts, but take care to arrive to what? To arrive to neutralization. That's what I need from this reaction. Easy to catch galvanic cell. Which of the following sentence is not correct about galvanic cell? What you have? Not correct is not right. Yes, I know. Anode is electrode at which oxidation occurs, or cathode of the galvanic cell, positive charge of the cathode only, or zinc is more difficult to be reduced than the copper in standard zinc copper in the cell, or cations move in the direction of the negative electrodes. Which one do you think? Yes, cations move in the direction of what? Negative electrode, not zinc copper. Yeah, negative electrode only. My dear students, we arrived to the end of this episode. Do you think it's easy to understand it? I think yeah. Concentrate for multi-choice because the answers are close to each other. Just word can be changed, just number can be changed. But I know you are good students. See you soon. Thank you and goodbye.